People don't care how much you know until they know how much you care. A tele-reminder from Teleradyo Marcelo, ang telearalan ng bawat malulenyo.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Good morning, Galpilarians! Welcome to our coverage of Teleradyo Marcelo, ang telearalan ng bawat malulenyo. Please like and follow us in our FB page and subscribe to our YouTube channel. I am Ma'am Girlie A. Cantela, your teacher broadcaster of the hour from Junior High School Science Department. Are you ready? Remember, learning is fun when shared with everyone. Let us first have a recall on the concepts that you have learned about the subatomic particles of an atom. Kindly type your answers on the comment box and feel free to like and share your thoughts on the FB page. Last week, we discussed all about the atom. And as a recall on the concepts about it, when we say atom, it refers to the building blocks of matter. They are too small to be seen with the unaided eye or even with the use of the ordinary light microscope. Scientists collected evidence that atoms are composed of three types of particles collectively referred to as subatomic particles. Can you recall what are the subatomic particles of an atom? Type your answers on the comment box. Very good. The subatomic particles of an atom are protons, neutrons, and electrons. Protons are positively charged particles. Neutrons are neutral, while electrons are negatively charged. How do we determine the number of protons and electrons in the subatomic particles of an atom? Any idea? Type your answers on the comment box. Very good. Number of protons is equal to the number of electrons, which is also equal to atomic number. Now, how do we compute the number of neutrons? Number of neutrons is equal to mass number minus the atomic number. Amazing! Your answers are all correct. Now, let us take a look at the objective of today's lesson. Our most essential learning competency is to use the periodic table to predict the chemical behavior of an element. Do you still remember the instruments used in physics? Can you name some of them? Type your answers on the comment box. Very good. We have meter sticks, magnets, protractor, weighing scale, and other instruments. How about in earth science? Can you name some of the devices used in earth science? Correct. Some of the tools or devices used are globe, world map, telescope, compass. How about in biology? Very good. Microscope is the common instrument used in biology. Now, what tool is commonly used in chemistry that shows different symbols of elements? Of course, it's the periodic table of elements. Very good. You've got it all correct. Quarter 3, Module 4 is about the periodic table of elements. Module 4 is divided into 4 lessons. Lesson 1 focuses on the development of the periodic table. How do you sort out things to put them in order? Do you sort them out according to color, size, or shape? What you go through in doing this simple task is similar to what is involved when the periodic table was put together. Those are basically the questions that lead on how the elements on the periodic table was arranged. It was basically the grouping and classifying of the elements based on the similarity of their structures and properties. The periodic table that we have today is a product of many revisions. At the time of Dalton's atomic theory, there were about 30 known elements. Equipped with more knowledge about the elements, chemists soon discovered more. Are you familiar with the periodic table of elements? Okay, that is great. Most of you are already familiar with the periodic table of elements. Can you describe how does it look like, or what can you see on the periodic table? Very good. All of the elements in the universe is shown on the periodic table. The elements are also organized based on its chemical properties. Now, let us discuss how the periodic table was developed and the scientists that made their contribution. Let us start with the Dobereiner triads, who was proposed by Johann Wolfgang Dobereiner. He grouped the elements into 3, which he called triads. For example, lithium, sodium, and potassium, and chlorine, bromine, and iodine. The next one is what we know as Newland's law of octaves by John A. Newland. According to Newland, if the chemical elements are arranged according to increasing atomic weight, those with similar physical and chemical properties occur after each interval of 7 elements. Newland was one of the first to detect a periodic pattern in the properties of the elements and anticipated later development of the periodic law. Let us have an example. Look at your periodic table. You can use your handmade periodic table. Look for the element lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. It clearly shows the pattern of the arrangement of the elements on the periodic table. The same with the next example. Magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Those elements are arranged based on its chemical properties. Mendeleev's periodic table. The person behind this is Dmitri Mendeleev. Dmitri Mendeleev and Lothar Meyer came up with the same idea, although they do not know each other. Meyer lived and worked in Germany, while Mendeleev in Russia. They have the same idea to arrange the elements in order of increasing atomic mass while putting in groups those with similar properties. Dmitri Mendeleev was known as the father of the periodic table. Here is the picture of two persons who made an important contribution on the arrangement of elements on the periodic table. We have Lothar Meyer and Dmitri Mendeleev. And finally, Henry Moseley. He arranged the elements according to their increasing atomic number instead of atomic mass. He discovered that the position of an element in the present periodic table is related to its atomic number and the arrangement of electrons to its energy level. He is known as the father of the modern periodic table. Take note, Dmitri Mendeleev is the father of the periodic table, while Henry Moseley is the father of the modern periodic table. This is the periodic table of elements that we use today, which has a slight revision but almost the same on the arrangement by Mendeleev. To sum up the concepts in Lesson 1, periodic table of elements shows all elements in the universe. It organizes the elements by chemical properties. Johann Wolfgang Dobereiner grouped the elements into three, which he called triads. Dmitri Mendeleev made the periodic table. He arranged the elements in order of increasing atomic mass. He is known as the father of the periodic table. Henry Moseley is known as the father of the modern periodic table. He arranged the elements based on its increasing atomic number. Do you have any questions? All right, let us now move to the next lesson. Lesson 2 is about basic features of the periodic table. But before we proceed, be sure that you have with you your periodic table of elements. It is for you to easily understand and catch up with the next lesson. Now, let us discuss the two basic features of the periodic table: the periods and the groups. What is a period? It is the horizontal rows on the periodic table of elements. Look at your periodic table. The numbers 1 to 7 on the left represents the period number. Notice that the lanthanide series below belongs to period 6, and the actinide series belongs to period 7. So, how many periods are there in the periodic table? Type your answers on the comment box. Very good. We have 7 periods. Now, let us have some examples. Again, be sure that you have with you your periodic table of elements. Let's start. The element calcium with a symbol of Ca has an atomic number of 20 and an atomic mass of 40. To what period the element calcium belongs? Type your answer on the comment box. Very good. It belongs to period 4. Next example, we have Pt or platinum with an atomic number of 78 and an atomic mass of 195. The element platinum belongs to what period? Correct. It belongs to period 6. Next, the element Sn or tin with an atomic number of 50 and an atomic mass of 119. This element belongs to what period? You are right. It belongs to period 5. Do you have any question? Great, you've learned so fast. Very good. Now, let us move to the second feature of the periodic table, the group or family. Group or family are vertical columns found in the periodic table. There are 18 numbered columns. Elements in group have similar chemical properties, just like the real family. How do we determine the group of elements on the periodic table? Group or family is classified into two. Group A are the representative elements, Group B the transition elements. These are the Group A elements of the periodic table, while elements on this part belongs to Group B. Now let us have an example. I will post the element, then you need to classify the group it belongs. All you have to do is to look on the upper label on the periodic table. This is from group 1A to 8A and 1B to 8B. Let's start. First, to what group do element calcium belongs? Type your answers on the comment box. Very good. Element calcium belongs to group 2A. Next, the element platinum belongs to what group? Very good. The answer is group 8B. And the last one, the element Sn or tin belongs to what group? Great. The answer is group 4A. This time, can you tell me what element is located in the following groups and periods? Let's have the first one. Name the element that belongs to group 4A and period 5. What is this element? The answer is tin. Very good. How about the element that can be found in group 5A and period 4? Right, the answer is arsenic. Very good. This time, find the element in group 7A and period 3. Very good. The answer is chlorine. Next, element group 8A and period 4. Type your answers on the comment box. Very good. The answer is krypton. Now that we have learned how the periodic table was developed and its different parts, let us now proceed to lesson 3, metals, nonmetals, metalloids, and inert gases. The elements on the periodic table can be classified as metals, nonmetals, metalloids, and inert or noble gases. Now let us discuss where do we find those elements on the periodic table. Let us start with the metals. Metals are elements found on the left side and center of the periodic table. This is where the metal elements located on the periodic table. How about the nonmetals? Nonmetals are elements on the right side except family 8A. This is where the nonmetals are located in the periodic table. The next one, the metalloids. Where is it located? Metalloids are elements bordering the zigzag line. Let us take a look at the periodic table of elements. Metalloids can be found here. These elements are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. And the next are the inert or noble gas. These elements belong to family 8A. Again, let us take a look at the periodic table. These are the inert or noble gas. It includes helium, neon, argon, krypton, xenon, and radon. Do you have any question? To test how well you understand the topic, let us have some example. All you have to do is to classify the elements as metal, nonmetal, metalloid, or inert or noble gas. Are you ready? Let's start. First element is magnesium. Is it metal, nonmetal, metalloid, or inert or noble gas? Very good. Magnesium is a metal. How about argon? Is it metal, nonmetal, metalloid, or inert or noble gas? Type your answers on the comment box. Correct. It is an inert or noble gas. Next we have silicon. How is silicon classified? Type your answers on the comment box. Very good. Silicon is a metalloid. And for the last example, we have oxygen. Is oxygen metal, nonmetal, metalloid, or inert gas? Great answer. Oxygen is nonmetal. It's so easy, right? For our last topic on the periodic table, we will describe how elements react with another substance. Lesson 4, Reactivity of Metals. What is the reactivity of metals? Reactivity of metal is another periodic property that can be observed from the periodic table relates to the property of metals. Generally, metals tend to give up electrons. The more easily an atom let go of its electrons, the more metallic it is. This tendency varies with different metals, increasing as you go down a group of representative elements and decreasing from left to right. To cite a few examples, consider the reaction of group 1 elements with water. Sodium reacts violently with water, decomposing it and producing much heat than often ignites the hydrogen released. Potassium also reacts readily with water, but with rubidium and cesium, the reaction involves a violent explosion. Reactivity is the ease and speed with which a metal reacts with another substance. The reactivity of metals can cause deterioration of materials. Corrosion is gradual wearing away of a metal due to interaction with other substances. There is an existing definite order of reactivity existing among metals and hydrogen according to their ability to displace one another. This arrangement is called the metal reactivity series or activity series of metals. The activity series is an arrangement of metals according to decreasing order of reactivity. Let us analyze the table showing the activity series of metals from the most reactive to the least reactive. Based on the table, the most reactive metal is potassium. while the least reactive is platinum. For our last activity, let us identify the most reactive metal from the given examples. Number 1. Among the following metals given such as potassium, platinum, silver, and lithium, which is the most reactive metal? Type your answer on the comment box. The answer is potassium. Very good. That is correct. For number 2, how about magnesium, tin, gold, and aluminum? Which is the most reactive? The answer is magnesium. You are correct. And for number 3, which is the most reactive among silver, calcium, sodium, and iron? The answer is sodium. Very good. Who among you got a perfect score? Very good, guys. Based on our discussion, I am confident that you have learned a lot from our lesson today. Before I end up, let me thank our beloved Delpilarians, especially to the grade 8 students who watched and participated in this morning's activity, and also to my dear science family, our OIC, Ma'am Mirna L. de la Cruz, our beloved principal, Dr. Maria Victoria C. Vivo, and to the staff of Teleradyo Marcelo. I would also like to thank my hardworking grade 8 science production team, our script writers, Ma'am Irene J. Benaventura and Ma'am Felicita C. Cunanan, our technical director, Ma'am Zenaida G. Martinez, and our contributor, Ma'am Jean F. Lagasca. Again, don't forget to like and follow our FB page and subscribe to our YouTube channel. That's all for today. Bye for now, Delpilarians. Till our next episode. Keep safe always, and God bless us all.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.